So here we are having to determine if the triangles are similar, and then to write a similarity statement, and then explain our reasoning. So that would be like which reason supports the triangles being similar, like side, 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 or side, angle, side. In the first one, they've labeled all the sides, and so we could do side, side, side. And I'll probably do that because I'm looking at the one on the right, and they only have 2 of the sides labeled, so I'm going to be forced to use side, angle, side there. And I want to show you both of those methods again, but I do want to point out that in the one on the left, they overlap at angle P, and so we could use side, angle, side as well. So you could use either reason for that one. But I'm going to go with side, side, side here, which means that for the larger triangle, I'm going to need to figure out my full side lengths, because obviously it's not 2. 6 and 8 and 2 is 8. And then over here, 4 and 8 is 12 for that length. And then 10 for that one. So for my small triangle, if I put those in order from smallest to largest, 4, 5, 6. And putting the other one smallest to largest would be 8, 10, 12. That kind of helps you because you're not having to think about if it's twisted around, which it is. This inner triangle's flipped version of this larger one. All of these would reduce to 1/2. So 1/2 would be the scale factor if I wanted that. They are equal to each other. So these are similar by side, side, side similarity. That's my reasoning, but I also need a similarity statement. So if I'm going to name them, got to be careful and name them in the right order. If I said P, T, Q for the small one, similar to, they overlap at P, so P matches in each of them. P to T is the short side, so I need to go across the short side for the big triangle, which would be P to R, and then to S. So that would be the similarity statement. The reasoning would be side, side, side. I've got my work for my showing my reasons there. Here we've got this bow tie picture. We've got our vertical angles in the middle. So vertical angles congruent, showing why those angles are congruent. We're going to test side, angle, side here. So in the smaller one, the smaller length is 3.5. And the larger length there is 4, and those surround that angle, which is why we can use them. And then here the order would be 7 and then 8. This is half of that, that's half of that. They reduce to half, they are equal in proportion. So side, angle, side, similarity is my reason, and do put similarity at the end because, you know, we have the congruence theorem as well, so we want to clarify the difference there. And then, so if I want to name the small one, if I said KMN, and again the first name that you make up that order, then I would match with K because they're vertical. K to M is the short length, so K to H because that's the shorter one, and then to G would be the similarity statement. For 9 and 10, it says sketch the triangles using the given description, explain whether the triangles can be similar. Here they're giving us the side lengths. It's said to sketch it, so if we have ABC, which is side lengths of 8, 10, and 14, obviously not drawn to scale, and then we have DEF, which has 16, 20, and 26. Being side, 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 we don't really need a picture. 8, 10, 14, those are in order. 16, 20, 26, those are in order. I'm just going to do like this, be lazy. These are my proportions. 8 over 16 is a half. 10 over 20 is a half. 14 and 26, not a half. So this is the one that doesn't work. These check out at half and half, but that's not half. So these ones are not similar. Not similar. And then on the right side here, we've got an angle. So for these, having a picture will be helpful. So just making a picture there. So if I've got A, B, C at 15 and 24, and B is 38, for that angle. And then DEF at 5, EF at 8, and then 38. So again, pictures not drawn to scale. So this would be looking at side angle side for the reason. And on the one on the left, if it was in order 15, 24, and then it would be 5 and 8. And if I divide here, I get 3. If I divide here, I get 3. That checks out. So these will be similar by side angle side similarity. And that's all I would have to put there. Here is a word problem for using similarity, and it says, in order to estimate the height of a tall pine tree, student places a mirror on the ground and stands where she can see the top of the tree as shown. The student is 6 feet tall and stands 3 feet from the mirror, which is 11 feet away from the base of the tree. What is the height of the pine tree? So we've got her height, her distance from the mirror, we've got the distance that the mirror is from the tree, and we've got the height of the tree, and so they're all in feet, which is good, as long as the girl's measurements are the same unit and the tree's measurements are the same unit, you're fine. So if we have 6 to 3 would be h to 11, and then cross multiplying, 66 is 3h. 22 is the height of the pine tree, so that's 22 feet for the height of the pine tree. Then we have, kind of adding on to that question, another student wants to do the same thing. The other student's 5.5 feet tall. So obviously the tree is the same height, and the question here is, if the mirror is to remain 3 feet from the student's feet, how far from the base of the tree should the mirror be placed? So in this question, it's 5.5 feet, and the mirror is still 3 feet, and then the height of the tree is still 22, but how far from the tree should we put the mirror? So 5.5 times x, 22 times 3, and so, let's see, 66 divided by 5.5 is 12 feet. So the mirror should be placed 12 feet from the tree for that student to work out because the height changed. The height of the student changed.